look at this example. We're given a function f of x on a closed interval. Closed interval means a interval that includes both endpoints. So when you see round parenthesis -1, 1, it means all the points from -1 to 1, but not including -1 and not including 1. So these points are endpoints. So if I use square brackets like this means I'm including the endpoints here, and in this case, you see I have square brackets on both ends. So here, both endpoints are included. This is just a little reminder. Okay, so I have a function defined on closed interval, and I'm looking for the absolute maximum value and absolute minimum value. So think about this. Here I have a function on a closed interval. Okay, right? For example, like this. Okay, then I can then say, oh, what is the largest function value? The largest function value here would be so-called absolute maximum, and the smallest function value I have, this value would be the absolute minimum. But my graph does not have to look like this. My graph could also look like this -1, this is 1, could look like this, right? Okay, so in this situation, you can see that the smallest function value I can get would be the function value from this point on the bottom, and by eyeballing it, I would still say this gives me the largest function value. But let's look at another possible example. I can also maybe have a function looking like this, and this time you can see that the largest function value is on this bump, the smallest function value is on the value of this, on the bottom of this value, right? So you can see here that the absolute maximum and the absolute minimum, they occur either at endpoints. For example, here the largest value happens at the endpoint, and same for the absolute minimum. And in this example, we see the absolute minimum happens at a critical point here, but the largest value happens at the endpoint, right? In this case, both the absolute maximum and absolute minimum, they occur at critical points. So I hope that from these three graphs, you can see that now the candidates for absolute max and absolute min, it will be all critical points lying on the interval, as well as the endpoints of the closed interval. So whatever closed interval you're working with, the endpoints would be candidates. So now this gives us some idea of what we're gonna do, right? So we're gonna first find all the candidates, and then we see what happens to those candidates. So step 1, I find all critical points. Okay, I'm being hypothetical, so let's say I find 3 critical points, 3 values. All right, then I evaluate the function at all critical points and the 2 endpoints. Okay, so remember the endpoints as well as the critical points are the candidates for absolute extremum. So we're gonna look at all of them. And so in this case, we're gonna just do evaluation. Okay, you plug in the number into the function f, and then you figure out what the function value is. Then you're gonna have, so in this case I have 5 values, and I'm gonna just handpick the largest one. The largest one gives me absolute maximum, and the smallest value gives me the absolute minimum. So you see, this is a very simple framework, very straightforward, simple framework. We started finding critical points, then we do evaluation for all candidates. So what are the candidates? Critical points and endpoints. Then you choose the largest one and the smallest one. That gives you the absolute max and absolute min. Okay? I'm going to erase this and I will implement this framework to solve this problem. Okay, there we go. So 1, find critical points. How do I find critical points? Do you remember? These are important. From the name of critical points, you know this is critical, so you have to know how to find critical points. First, find f prime. So here I have 12x squared minus 6x. I'm gonna set f prime equal to 0 and solve for x. Okay, because the solution will give me critical points. So here I factor out, if I look at this polynomial, I see the greatest common factor is 6 and x. So factor out 6x, I get 2x minus 1 equal to 0. So this gives me either x equal to 0 or 2x minus 1 equal to 0. And here I'm writing out baby steps. If you know how, if you from here you know what the answers are, feel free to just write down the answer. So then I further see that this first one, x equals 0. This I have 2x equals 1 and x equals 1 over 2. So and x equals 1 over 2. So I have 2 critical points, and I want to double check that the values I get are sitting inside this interval. If it's outside the interval, then I don't care. Okay, then I just ignore it. 0, both the 0 and the 1/2 are sitting inside the interval minus 1 and 1, so we're good. Okay, and step 2, I'm gonna do what? I'm gonna evaluate my my candidates. So f of 0, f of 1/2, this is values for critical points, but I need to also evaluate f at the 2 endpoints. So in this case, you see it's minus 1 and 1. Okay, so I'm gonna use the given function do evaluation. So this plug 0 into x, this is 0 because 0 minus 0. And f of 1/2, oh, this is a little difficult, so let me write it out. Minus 3 times 1/2 squared. So this is 4 times 1/8 minus 3 times 1/4. Okay, so simplify this. Let me write this 4 over 8 as 2 over 4 and minus 3 over 4. So you see here I have minus 1/4. Okay, so I have 2 values, 0 and then minus 1/4. Then we have f of negative 1. So that is 4 times negative 1 to the power 3 is still negative 1 minus 3 times 1. So that's a minus 4 minus 3, so that's a minus 7. Okay, last, f of 1, this is a 4 minus 3, so this gives me 1. Okay, so I look at the 4 values that I found, 0, 1, minus 7, and minus 1/4. Now, which one's the largest? The largest is this one, 1. So that would be my absolute maximum. What is the smallest one? So I have 2 negative values. So minus 7 is smaller than minus 1/4, therefore this is smallest value. So step 3, I'm gonna say absolute maximum value is f of minus 1, oh, I'm sorry, f of 1 equal to 1, and the absolute minimum value is f of this one minus 1 equal to minus 7. Okay, so this is how we find the absolute maximum value and absolute minimum value on a closed interval.